Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which helps us in printing level order traversal of a binary tree line by line. First, let us take an example. As you can see, the level order traversal of this tree is 1. We have 2 and 3 in the next line, which is also the next level, and 4 and 5 in the next line, which is the third level. Now, let us see the algorithm. In this, a different approach using one queue is discussed. First, we insert the root and a null element into the queue. The null element acts as a delimiter. Next, we pop from the top of the queue and add its left and right nodes to the end of the queue, and then we print the top of the queue. We continue this process till the queue becomes empty. Let us have a sample tree to test our algorithm. Note that we are using a queue data structure. First, we push the root node, which is 1, into the queue. Also, we push a null delimiter to mark the end of each level. Since the queue is not empty, we enter the while loop and pop the front element from the queue and assign it to node cur. Since cur is not pointing to null, we go to the else part and push the left and right children of cur. So 2 and 3 will be enqueued. Next, we print cur's data. So 1 is printed. Again, as the queue is not empty, we continue with the while loop and now cur will point to null and null will be dequeued. Since the cur node is pointing to null, we check if the queue is not empty. As it is true, we add a null node and bring the cursor to a new line for printing next level in next line. We continue with the while loop as the queue is not empty. Now, cur will point to 2 and 2 will be dequeued. Again, as cur is not pointing to null, we go to the else part and now enqueue the left and right children of 2. So, 4 and 5 will be enqueued. Next, we print data of cur. Note that the cursor was at a new line, so 2 will be printed on a new line. We continue with the while loop and now cur will point to 3 and 3 will be dequeued. Again, as cur is not null, we go to the else part and since node 3 does not have any children, nothing is enqueued and we print 3. Since the queue is not empty, we pop the front element from the queue. So, cur will now point to null. As cur is pointing to null, the if condition is satisfied and we check if queue is not empty. Since it is true, we add a null delimiter and bring the cursor to a new line. We continue with the while loop and now cur will point to 4, which is the front element of the queue. We go to the else part and now, as 4 does not have any children, we print data of cur. We continue with the while loop and now cur will point to 5 and 5 will be dequeued. Since cur is not null, we go to the else part and print 5. Next, cur will point to null and null will be dequeued. Now, as the queue is empty, the inner if statement inside the first if of the while loop is not satisfied and in the next iteration, the condition of the while loop is not satisfied as the queue is empty. Hence, we break out of the while loop and finish execution for this program. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.